Good day, everyone. We are about to go through plant design and economics, right? You don't know plant design and economics, so concerned about everything in the chemical industry, right? How to evaluate pressure drop, how to do optimize, and how to even do the economics for some equipment. So basically, for even for an entire plant, right? So over here, first we are about to look at the optimization, right? How to optimize. Right, so the first question here is a rectangular tank with a square base is constructed from a 5 mm steel plate, and they give us a capacity of 8 cubic meters, which is the volume. So we want to determine the optimum dimensions if first the tank has a closed top and if the tank has an open top, right? So basically it's an optimization where we have to find objective function. We need to have our constraints that we can be able to solve our question, right? So over here I see that the constraint over here is the volume over here, which is 8 meters cube, right? Then over here you can find the area, right, of a rectangular tank which has a square base, right? So if it has a square base, so doing for the eye first, right, which has a closed door. So if it has a square base, meaning that the square base, the area for the square base will be L times L, right, which gives us an L squared. But we have two of them, which is the base and the top. So that becomes 2L squared, right? Then we have fourth size, right? So the size over there, apart from the top and the base, we have other fourth size, which the area becomes the length times the height, right? So we have four of them, right? So it's 4 times what the length times what the height. And over here, you know that the volume will be equal to what? LBH. But since it's a square base, the base becomes the length, so L squared H, right? So from here, I can make one variable, the subject, which is the H. So H becomes 8 over L squared, which I can put that one inside the area formula. So I have 4L, so I have 8 divided by what? L squared, which gives me 2L plus what? 32 over L, that's 8 times 4. Over here, I can differentiate. So the L, that's area with respect to L, gives us 4L minus 32 over what? L squared. Right, that's the derivative. And at the optimum, right, so we know that at the optimum, the L is equal to 0. Right, so since the L is equal to 0, I can actually find the length, the optimum length, right? So 4L will be equal to 32 divided by L squared, where I have L cubed, which is 32 divided by 4, and I have 8. Right, so if I want to find L becomes what? The cubic root of 8, which is what? 2 meters, right? So that's the optimum what? Length. And how to find the optimum height? That's 8 divided by L cubed from the first equation. So 8 divided by squared. So 2 squared. So 8 divided by 4, which is also 2 meters, right? So the height over here, the length over here gives us what? The optimum dimensions, right? That we can use if the tank has what? A closed top. Did you get it? But let's see when the tank has an open top over. When it has an open top, how do we approach this one too? So if I have I, that one to volume 8 meter cube, which is L squared H. So making H the subject, I'll have 8 divided by L squared. So let's see the area. So since the top has been opened, meaning that you will have just the area of the base, which is what? L squared. You don't have any 2. But still the size remains 4. So 4LH, right? So over here, putting in the H, right? So over L squared, right? So A becomes L squared, right? Plus 32 divided by L. And did you get it? So over here, the ADL, right, becomes 2L minus 32 over L squared, right? So as usual, at the optimum, right, the L is equal to 0. So 2L equal 32 divided by L squared. So we have L cubed to be 32 divided by 2. So having so L will be equal to the cubic root of 32 divided by 2, right? So let's see, we have the cubic roots, then we have 32 divided by 2. That gives me 2.52 meters, right? So that's actually, then we can actually also get the height. This is divided by 2.52 squared. Alright, so we have 8 divided by 2.52 squared. Alright, 2.52 squared. Alright, so that gives me a height of 1.30 meters, right? So we have these two, right? So we have the length, then we have the height. So if we don't have an open top, this is actually the dimensions or the optimum what dimensions that you can use. So normally based on, this is a rectangular tank with a square base. So if you can have a cylinder, so you just have to know your constraints and you have to know your objective function. From the constraints, you make something that's out there so that you can have the objective function in just one variable so that the differentiation can be easy. Then at the optimum, when it's equal to 0, you can solve for one variable. Then you use your constraints, you can use that one to actually calculate for whatever you want to calculate for, right? So this is for the optimization side, which is very easy to go about, right? Yeah, thank you.